The night the telescope caught it, silence hit the control room like gravity itself. No one expected movement, not from a visitor that doesn't belong to our solar system. Yet, on that night, a thin line of light appeared on the edge of 3I Atlas, a light that wasn't reflected, but ejected. It wasn't supposed to happen. Comets from other star systems, interstellar objects like Oumuamua or Borisov, usually drift through space like lost debris, frozen and passive. They do not roar, they do not breathe, but Atlas did. For a few seconds, instruments from the Mauna Kea Observatory registered a plume, a jet of material shooting from its nucleus, accelerating it, twisting its trajectory slightly off course. It was as if this cosmic vagabond had decided to speak. A fragment from another sun, older than our entire civilization, just broke its silence. The data spread like wildfire across astronomy networks. Spectral readings, velocity shifts, anomalous heat signatures, all consistent with an active outgassing. But the real shock wasn't in the physics. It was in the question that no one could answer. Why would an interstellar object eject material in deep space, far from any star that could heat it? That single jet changed everything. Because if 3I Atlas isn't just a frozen relic, if it can release energy on its own, then the boundaries of what we call lifeless matter may not be as clear as we thought. And somewhere, between the hum of data and the echo of that cosmic jet, humanity realized something unsettling. The universe might still be full of unseen engines, moving with purpose through the dark. For weeks, astronomers rechecked the readings, searching for an error that never came. The signature of the jet from 3I Atlas was unmistakable. A brief but measurable outflow of volatile material, captured simultaneously by optical telescopes and infrared sensors. What startled scientists most was its timing. The outburst occurred when Atlas was already far from the sun, beyond the region where heat could trigger traditional sublimation. Normally, when comets expel material, it's because solar radiation warms their icy nuclei. Gas escapes, dust follows, and a tail forms. But 3I Atlas, speeding through interstellar space, was cold. Far too cold for ice to sublimate. So something else was driving that jet. Spectral analysis hinted at complex organic molecules and carbon-based volatiles. These weren't the pristine ices of a newborn system. They were processed, aged, altered by time and radiation. That discovery pointed to a deep, almost haunting idea. Atlas might be a fragment of a planetesimal core, the remnant of a world that once orbited another star. A shard from a system torn apart long ago. The Mauna Kea data were later cross-checked with follow-up observations from the Subaru telescope and the Very Large Telescope in Chile. Each confirmed the same anomaly, a directed release of material, not random venting. A jet, angled and pulsed. The energy output, though brief, implied an internal reservoir, some form of trapped heat or chemical instability buried beneath its crust. That's when theories began to diverge. Some proposed cryovolcanism, internal pressure caused by exotic ices like nitrogen or carbon monoxide expanding in sealed cavities. Others went further, suggesting that long-term cosmic radiation had rearranged Atlas's molecular bonds, storing latent energy that could suddenly discharge as heat when certain thresholds were crossed. A smaller group, quietly but insistently, began to wonder if Atlas wasn't entirely inert at all. What if its composition allowed for self-sustaining reactions, similar to primitive chemistry that once seeded the first forms of metabolism on Earth? Not life as we know it, but pre-life, a mechanism that bridges the gap between geology and biology. As data accumulated, one detail refused to fit neatly: the precision of the jet's direction. It wasn't random, nor evenly distributed. It appeared controlled, or at least patterned, as if responding to internal geometry or magnetic alignment. That patterning kept haunting researchers, whispering of organization in what should be chaos. And in that realization, astronomy met philosophy. Perhaps not everything that behaves actively in space is alive, but maybe not everything that acts inert is dead either. The question now wasn't how Atlas fired its jet, but what kind of story this interstellar traveler was trying to tell, written in physics, chemistry, and the faintest breath of motion. For decades, we've imagined comets as the simplest of wanderers, chunks of ice and dust, tumbling through the dark, ruled only by gravity and heat. We were taught that once an object drifts far from any star, it becomes nothing more than frozen silence. 3I Atlas shattered that comfort. At first, scientists tried to fit its behavior into old templates. It must have retained solar heat from its flyby, one group argued. Or maybe a micrometeorite impact released trapped gases. Those explanations felt safe, mechanical, predictable, familiar, yet none aligned with the data. The temperature was too low, the timing too late, the energy too focused. That's when the illusion began to break. Our entire framework for understanding cosmic inactivity relied on the assumption that energy only flows from the outside in, that objects need a nearby star to wake them. But what if some carry an internal clock, mechanisms that trigger from within, independent of any external source? Imagine standing beside a frozen lake on Earth. You'd assume it's motionless until the ice cracks under unseen tension. Atlas may be like that, not a passive rock, but a structure with memory, a layered body holding ancient stress until something deep inside decides to move. And here's where human perception collides with cosmic truth. We see stillness and assume death. We measure silence and call it emptiness. But in space, stillness can hide tremendous tension, pressure, radiation fatigue, molecular transformations waiting centuries for release. Atlas didn't break physics. It revealed how shallow our definitions had become. The team at the European Southern Observatory ran dynamic simulations. When they modeled a delayed chemical reaction beneath the surface, one triggered by microstructural collapse or decay, the data matched the jet's direction and strength almost perfectly. That was the first time scientists realized this wasn't chaos, it was sequence. And that's the illusion we had to abandon, that space is static and time moves only forward. Because in interstellar debris, time folds. Energy doesn't always dissipate. Sometimes it waits, compressed, ready to act, when conditions whisper yes. Suddenly, Atlas was no longer just an interloper. It was evidence that motion in the void can arise not from external push, but from internal design. Nature's quiet experiment, running in the coldest laboratory imaginable. The first rung on the ladder was the light itself. When the Subaru telescope caught that sharp flicker near Atlas's nucleus, it wasn't random noise. The intensity curve rose and fell over 9.6 minutes, consistent with a directed emission, not an impact flash. The signature repeated twice over the next 40 hours, faint but measurable. It wasn't a glitch. It was a heartbeat. The second rung came from spectroscopy. As scientists decomposed the light, they found spectral lines of carbon monoxide and cyanide radicals, compounds that vaporize only under sudden bursts of heat or chemical instability. Yet the surrounding dust temperature was barely 40 Kelvin. That contradiction was the evidence everyone feared. Something inside Atlas had generated its own heat. The third rung arrived from orbit recalculations. After the jet, Atlas's trajectory shifted, not dramatically, but enough to measure. Its velocity changed by just a few centimeters per second, confirming the jet's thrust was real, not illusionary. You could almost picture it nudging itself, correcting its path across the abyss. The universe had written its signature in motion. Then came the fourth rung, the one that changed speculation into conviction. Infrared instruments aboard the James Webb Space Telescope were aimed at the coordinates where Atlas was last visible. Webb's sensors picked up a residual plume, dust rich in silicates and organics, glowing faintly in mid-infrared wavelengths. That composition didn't match any known comet from our system. It was denser, darker, more carbon-loaded, evidence that Atlas had spent millions of years drifting through radiation fields, absorbing energy like a sponge. The data formed a chain too elegant to ignore. Observation, pattern, hypothesis, implication. Each link pulled us closer to a realization that felt almost biological. Atlas wasn't merely reacting to physics, it was responding to it. Its structure stored potential, then chose a moment to release it. Not life, perhaps, but an echo of its logic. One researcher from ESO described it perfectly in her report. "We are witnessing matter remembering." That single phrase lingered through scientific circles, haunting every late-night data review. Because if interstellar fragments can store and discharge energy in rhythmic bursts, without a nearby star, without external pressure, then they may be more than remnants of creation. They may be mechanisms still participating in it. And when the final composite images arrived, the faint jet frozen against the black, it no longer looked like an accident. It looked like a whisper from the interstellar medium itself, telling us that even in silence, the cosmos has a pulse. There's a strange kind of unease that comes when the universe starts acting alive. For centuries, humanity has drawn comfort from categories, living and non-living, active and dead. They've kept the cosmos predictable. But 3I Atlas shattered that boundary with one flash of expelled matter, one cosmic breath in the dark. If energy can rise from within cold stone, what separates a comet from a cell? If motion can be born without heat, is there still such a thing as true stillness? Philosophers of science began revisiting an old question. Is life a special case, or a gradient of organization? Maybe the same laws that drive a comet's eruption also drive the metabolism of cells, both patterns of energy-seeking release, both built upon instability-seeking balance. Carl Sagan once said, "We are a way for the cosmos to know itself." But Atlas forces a subtle rewrite. Maybe the cosmos already does know itself, through countless processes we simply never recognized as alive. Perhaps life is not an exception to physics, but its natural continuation, echoing in chemistry, in dust, in the cold movements of interstellar wanderers. The counter-arguments came fast. Skeptics insisted there's no intelligence in the jet, no awareness, only thermodynamics. It's chemistry, they said, not consciousness. And they're right, in part. Yet chemistry is where consciousness began. Complexity has to start somewhere. The fact that inert matter can mimic decision, that a frozen fragment can wait, build tension, and release, reminds us that the universe's creativity doesn't need biology to express itself. Some cosmochemists proposed a new framework, proto-autonomy, systems that self-regulate without life, reacting to internal conditions instead of external forces. Under that definition, Atlas becomes more than debris. It becomes an example of universal responsiveness, the capacity for matter to self-modulate. In that idea lies something quietly terrifying. The universe might be littered with precursors, not just to life as we know it, but to agency itself, mechanisms that test physics at its edges, long before consciousness ever evolved. We used to look at stars and ask where life could exist. Now, we look into the dark between them and wonder whether the difference between life and non-life is just a question of timing, of when stored energy finally chooses to speak. And somewhere between a philosopher's doubt and an astronomer's data table, the same realization echoes. Perhaps the universe has never been silent at all. We were just listening for the wrong kind of voice. When the first models of 3I Atlas's jet were published, engineers and astrobiologists both leaned forward. Not because they had found proof of life, but because they saw something even more revolutionary, a natural engine operating without external fuel. That small ejection of matter, so brief it barely left a trace, could rewrite propulsion science. If Atlas can store energy for centuries and release it in a single burst, then maybe we can learn to build machines that do the same, systems that charge themselves through cosmic radiation, waiting patiently for a command that may come decades later. Silent propulsion, self-heating mechanisms, autonomous power cycles derived from interstellar chemistry. It sounds like science fiction, but so did ion drives once. Researchers at NASA's Jet Propulsion Laboratory have already begun studying the material analogs, testing how exotic ices and carbon compounds react to cosmic ray bombardment. Early simulations show that under extreme vacuum and radiation, certain organic matrices can restructure, trapping charge within molecular bonds. Release them at the right threshold, and you get a miniature explosion, a perfect cosmic jet in a lab. That's not just physics. That's potential architecture for the next era of exploration. Imagine probes that drift for centuries between stars, waking only when internal chemistry reignites. Imagine terraforming systems designed not to burn energy constantly, but to store it, like Atlas did, in cycles of dormancy and eruption. And then there's the philosophical technology, the kind that changes how we think rather than what we build. If interstellar matter can demonstrate self-contained activity, our definitions of alien must expand. Life might not always be biological, it might be energetic, existing as patterns of recurrence, bursts of organization, or long pauses before motion. In that sense, Atlas could represent not the beginning of a mystery, but the first data point of a new taxonomy of existence. Astrobiologists are already updating their frameworks for habitability, no longer limited to warmth, atmosphere, or water, but to persistence of pattern. A system capable of holding and releasing energy could, in principle, evolve toward complexity over cosmic timescales. And so the next time a telescope detects another faint traveler cutting through our solar system, no one will dismiss it as mere rock. The algorithms will scan for jets, pulses, sequences, for the fingerprints of internal design. Because from now on, the silence between stars won't feel empty anymore. It will feel pregnant, full of stored momentum, waiting for its turn to ignite. When I first saw the data visualizations of 3I Atlas, I couldn't help but think of people, of how we, too, spend most of our lives storing energy we barely understand, dreams deferred, ideas dormant, emotions frozen until the right moment cracks the surface. Maybe that's the quiet parallel. The universe and the human mind both hold potential energy waiting to become motion. Atlas's outburst wasn't constant, it was rare, brief, and transformative, and that rhythm mirrors our own lives more than we realize. We're taught to see progress as continuous, always burning, always visible, but maybe nature's truer model is cyclic. Moments of stillness followed by sudden ignition. Scientists call it cryovolcanism. Poets might call it awakening. Either way, it tells us that stillness is never final. Think about it. A fragment wandering between stars, alone for millions of years, suddenly releases its inner pressure and changes direction. How different is that from the moments when a single thought, long buried, reshapes the course of a human life? We think of movement as reaction, but sometimes it's revelation. Something deep inside decides to act. That's the emotional truth behind the data. The cosmos behaves like memory. It stores tension, organizes it, and releases it in signals that travel across time. Every star, every comet, every molecule participates in this dance of retention and release. And so do we. Maybe that's why Atlas struck such a chord. It didn't just challenge physics, it mirrored psychology. The idea that even in isolation, in the frozen parts of existence, motion can still be born, not from the outside world, but from the silent accumulation of inner potential. When astronomers talk about the active inert, they describe things that appear lifeless but hide power. Humanity has its own version of that. Untapped creativity, compassion, and insight sleeping beneath routine. Atlas reminds us that activation doesn't require proximity to a star. Sometimes the spark comes from within, and perhaps that's the hidden reason we explore the universe at all. We're not only searching for other forms of life, we're searching for confirmation that stillness isn't the end, that even the coldest fragments of creation can still move, still express, still surprise. In that sense, Atlas isn't just a story about a comet. It's a mirror held up to consciousness itself, a message whispered across interstellar space that says, you too are a vessel of stored light. In the end, 3I Atlas drifted back into silence, its jet extinguished, its trajectory bending into the endless dark. Telescopes lost sight of it, and data streams fell quiet. But something remained, the echo of that single act, that uninvited eruption that dared to defy stillness. We will never see it again. It has already crossed beyond the reach of our instruments, carrying within it the record of its own awakening. Yet maybe that's the point. The universe isn't asking us to observe everything forever. It's asking us to notice when something impossible happens and to remember it long after it's gone. Atlas taught us that energy and silence are not opposites. They are partners, waiting, feeding, releasing, returning. It revealed that even in the coldest domains of the cosmos, there is motion that cannot be predicted, only witnessed. And in that revelation lies a truth both cosmic and intimate. Perhaps we, too, are interstellar objects in our own way, wandering, gathering, storing, until the moment our internal gravity finally releases what we were meant to create. So when you look up tonight, think of that solitary traveler from another sun, the one that fired a jet in the dark and changed how we define motion itself. Somewhere out there, 3I Atlas is still flying, silent again, but no longer inert. Because once something speaks in the void is never the same. Do you believe this discovery redefines what alive means in the universe? Or are we still missing the deeper mechanism behind its awakening? Tell me below.